The Voronoi tool produces a set of cells which are tessellated in a region which we call a boundary, and to produce a Voronoi we can give it a set of points, as you can see here, and if I change the location of the points you can see that those cells change. But how are those cells produced is about this video. So if we just double click on the canvas and search for VOR, we have a Voronoi, and I'm going to talk about the Voronoi, but the Voronoi 3D is another video. In another video I will talk about how we produce bubbles that collide and are just confined in a box. So Voronoi we can be just also reached in the mesh part and the triangulation sub menu. So you can go to the triangulation and choose the Voronoi. The first thing we have to give to the Voronoi is the points, and those points should be randomly distributed because Voronoi is actually feeding on randomly distributed data. So if I give these points to the points input, you can see that the Voronoi cells emerge. You can also give a boundary that is a rectangle for confining and containment of the Voronoi cells, and I have just drawn a rectangle in Rhino and imported as a curve in the params menu and geometry and gave it to the boundary, and you can see that the Voronoi cells are just produced. The next point is that if we give it a simple distributed points of a grid of points, let me give an example. If I produce a point and array it in the X for 5 and 5 and 1 and give this set of points to Voronoi, you can see that the results is just a set of rectangles, and if I change those points you can see that the Voronoi cells emerge. So the first and most important thing about Voronoi is to use randomly distributed points, and it's better to be in a plane, because if you just check this out, I just move these points out into the Z direction, the results don't change because the Voronoi is produced in a plane. So if I just move those points, you can see it's projected and then the results are drawn. The next point about Voronoi is that it has a radius. And what is radius? We can define Voronoi as two methods in producing the cells. The first method is mathematical. I will talk about it. It's the Delany mesh. And the second method is just a simple geometrical method. The second method is the geometrical method, and it uses a radius. So if I give a number to this radius input, and let me just give a number here, you can see that actually you can produce the Voronoi cells by drawing a circle around the points and growing the radius. The radius grows, and what happens is that the circles collide, and after collision happens, the line is drawn, but the circle just continues to grow. So if I increase the number of the radius, you can see those circles collide, and let the boundary be bigger so you can see the circles. And why we need a boundary actually happens is that when we increase those circles, you can see that I increase the radius, the inner circles just make the cells, that's okay, but the outer points, it's just like a bubble. It grows and it doesn't come to an end because those lines will continue to go outwards to infinity, and there's not a confining boundary for it. So if I just increase it to like 2400, you can see that it just, if we delete the boundary and increase the number, you can see that the cells grow, but Grasshopper will produce a square to define the boundary. So even if you don't give it a boundary, Grasshopper will do that for you, and that's the result. So if I just decrease the number, you can see that those cells or bubbles are being produced, and you can have the outer curve of those regions by going to the intersect menu and choosing region union. And what actually happens is that it unites the regions, and let me just preview off for the Voronoi cells, and you can see that the result is the outer curve of the cells, and you can use it to produce boundaries of those circles. And if I connect a surface to it, you can see the results. And to have this in a better result, we can go to the surface and choose boundary, and boundary will just make holes in the region if the curve is located in another curve. So this is all about circles growing and colliding and producing those lines. The first method, which I talked before, is a mathematical one, and what it actually is that if we connect those points together with a rectangle, with a triangle, excuse me, if we connect them with a triangle, and that's the Delaunay mesh or Delaunay edge or Delaunay line, you can see that the triangle is the base of the Voronoi cells. And if I zoom in, you can see that the line of the Voronoi is a line which makes the triangle edges split into half, and it's perpendicular. So it's a mediator that is perpendicular to the edge of the triangle. And you can see it here, and again here, and again here, and it continues to grow until it hits at a center. So this is the point. But let's make this in Grasshopper. If I go to the mesh menu and choose the Delaunay mesh and connect those points, you can see that the Delaunay mesh, let's just move those points to see the triangles. Okay. If we don't define a boundary, the line here, the line that is it's a mediator, it continues again to infinity because it doesn't have a boundary. So we easily define a boundary by producing a rectangle and give it to go to the params and the curve in geometry and import the curve as a boundary. So you can see that the control is better. The third point, the third tip about Voronoi is it has a plane. So basically, if I give it a XY plane and extract the origin and move the origin up, you can see that it produces the Voronoi cells in that plane. So the last tip is to talk about the plane. What we can do to play with this plane is to let me just draw a rectangle, go to the surface in Rhino and draw a rectangle here, and that's a surface. Let's import that into Grasshopper, a great feature in Grasshopper is that you can use a surface, if it's a flat surface, as a plane, because the input is a plane kind of type, but the surface is not. If you connect a plane to it, let me just connect a plane, you can see that Grasshopper produces a plane in the corner and uses that as the plane. So a great way of producing a parametric plane so we can just change and see the result is to draw a surface and give it to the plane. And let's see what happens. If I rotate this plane, you can see that the Voronoi cells are being drawn into that plane. So you can change that plane to produce different cells based on that points and the boundary. And you can see that it can be, let me just move this outwards, and you can see that it's a great way to see how Voronoi is produced. The last part is about the Voronoi, is you can produce random points. Let me explain this. And if I go to the params menu and choose surface, produce a surface, you can make randomly distributed point on that surface. I will be talking about that tool, which is called populate geometry, later on, but you can connect a populate geometry to the surface and tell how many points you need, something maybe like 200, and change the number. You can see that it increases the randomly distributed points. You can give it a seed, so you can change the situation, different like 400 points, but it's in a different kind of distribution. And if I give this to the points, you can see that those cells, if I turn off the populate points, you can see that those points produce the Voronoi cells. So you can produce it by changing the seeds and increasing or decreasing. There's a lot of ways we can work with Voronoi cells. We can increase the points in a place and make the cells just be distributed more in a place. I will be talking about these in a video tutorial. I will be making a course on Grasshopper in the future, and I will be talking more and more how you can produce beautiful and parametric geometry with Voronoi. Even you can go and step into the mesh thing, because Grasshopper was really weak at using mesh, but we can use different plugins to produce mesh, Voronoi mesh, and those techniques I will be talking about in a course. So this is a short video tutorial about Voronoi and how you can produce it and how you can use it. You can easily bake those cells and see that they are just let me choose all of them, expect the rectangle, and you can see that those cells are region, they are closed, and you can work with them, you can offset them, you can extrude them, and have many different results. And thank you for watching this video. If you have any comments or questions about Grasshopper commands, because I will be talking about most of the Grasshopper commands in the future, feel free to put a comment in this video or other videos, and I will put the command on the first list, and I will just try to produce it as soon as possible. Thank you for watching.